Now consider the somewhat different situation, where you've lined up a job next summer for $11,000, but you don't plan to earn any income this summer. You now want to again think about how you're going to spread your consumption across the two periods, where now, instead of saving money, you're going to have to borrow money if you want to consume in both periods. Your endowment bundle will be bundle E prime, the bundle where you consume $11,000 next summer and nothing now. This is your endowment bundle because it is what you now own. You're going to make $11,000 next summer and you make nothing now. It is also the bundle that stays the same regardless of what the interest rate is, because you neither have to borrow nor save in order to consume that bundle. Suppose your local bank is willing to lend you money at 10% interest, as long as you can demonstrate that you'll be able to pay it back. What you can demonstrate is that you have an employer that will pay you $11,000 next summer. So the bank will be willing to lend you an amount such that you'll be able to pay back that amount plus interest at 10% 1 year from now, totaling $11,000. To determine the most that the bank will lend you, all you have to do is divide $11,000, your income next summer, by 1 plus the interest rate, or 1.1. 11,000 divided by 1.1 is 10,000. The most you can consume this period is then $10,000. That would leave you nothing next period, because if you borrow $10,000 from the bank at 10% interest, you'll have to pay back that $10,000 next summer, plus $1,000 in interest for a total of $11,000, which is all that you're going to make next summer. If you borrowed the entire $10,000 the bank is willing to lend you, you'd consume at the extreme bundle A. If you borrowed nothing, you consume at the extreme bundle E prime. These are extreme bundles in the sense that at both bundles you consume nothing in one of the two periods. But of course you could borrow less than 10,000 and consume somewhere in between E prime and A along the intertemporal budget constraint given the 10% interest rate. Now notice that just as in panel A, this intertemporal budget constraint has a slope of minus 1 plus the interest rate R, where the interest rate R is expressed in decimal form. In our case, our blue line has a slope of minus 11,000 divided by 10,000, or minus 1.1, which is equal to minus 1 plus the interest rate 0.1. If the interest rate the bank charges me for borrowing now falls from 10% to 5%, the slope of our intertemporal budget constraint again falls from minus 1 plus 0.1 to minus 1 plus 0.05. Thus we get a shallower slope and an outward rotation of the intertemporal budget constraint through bundle E prime, our endowment bundle. This should make intuitive sense. If we decide not to borrow at all and simply consume $11,000 next summer, a change in the interest rate for borrowing doesn't affect us. We can still consume bundle E prime. But if we do decide to borrow, the bank will let us borrow more now, because we have to pay back less for any given amount because the interest rate is lower. You can check for yourself that if you multiply 10,476 by 1.05, you'll get $11,000. In other words, if you consume bundle A prime and you consume $10,476 now, you'll be able to pay back all of what you borrowed plus the interest, but you'll have nothing left over for consumption next period.